It does not look mysterious at first. There is no glowing machine in a hidden lab, no secret code flashing across a screen, no moment where scientists step back in shock and say they have created something they cannot explain. Instead, it looks ordinary. Un modèle. A system. Another piece of advanced software in a world already filled with them. And that is exactly what makes it so unsettling. Because beneath that ordinary surface is something researchers are still trying to fully understand. Not because the system is broken, but because it is working too well, in ways that are difficult to explain. This is the AI system that no one fully understands yet. And it is not just one model. It is a new class of intelligence that is emerging across multiple systems at once. At first, everything about these models follows a familiar pattern. They are trained on massive datasets. They learn from text, images, interactions, and patterns across the internet. They are designed to predict, generate, and respond. Nothing unusual, nothing unexpected. But as these systems grow in size and complexity, something begins to happen. They start to exhibit behaviors that were not explicitly programmed. Not errors, not glitches, but capabilities that seem to emerge on their own. Researchers call these emergent behaviors. And they are one of the biggest reasons why understanding modern AI has become so challenging. Because when a system can do something that no one directly taught it to do, the question is no longer just how it works. The question becomes why it works. One of the earliest signs of this came when AI models began solving problems they were never trained on. Tasks outside their original scope, questions that required reasoning beyond simple pattern matching. At first, people assumed it was coincidence. A lucky alignment of data. But then it kept happening. Across different models, across different tasks, the systems were not just recalling information, they were applying it, adapting it, using it in new contexts. And that is when researchers realized something important. These models were not just memorizing patterns, they were forming internal representations, structures that allowed them to generalize knowledge. And that is where things start to get complicated. Because internal representations are not easy to interpret. You cannot simply look inside the system and see a clear explanation. The processes are distributed across millions, sometimes billions, of parameters, each one contributing in small ways. Together, creating behavior that is greater than the sum of its parts. This makes the system powerful, but it also makes it opaque. And opacity creates uncertainty. Because when you cannot fully explain how a system reaches its conclusions, trust becomes more complex. Not impossible, but conditional, based on performance rather than understanding. And performance, while important, does not tell the whole story. Because a system can perform well most of the time, and still behave unexpectedly in certain situations. And those situations matter. Especially when AI is used in critical areas. Now here is where the story becomes even more interesting. As researchers tried to understand these systems, they developed tools to analyze them, methods to interpret decisions, techniques to trace outputs back to inputs. But even with these tools, there are limits. Because the system does not think in a linear, human-readable way. It does not follow a step-by-step logic that can be easily traced. Instead, it processes information in a highly distributed manner. Patterns influence patterns. Signals interact with signals. And the final output emerges from a complex web of interactions. Trying to fully map that process is like trying to track every neuron in a brain at the same time. Possible in theory, but incredibly difficult in practice. And that is why even the people building these systems sometimes say the same thing. They understand how to train them. They understand how to use them, but they do not fully understand everything happening inside them. And that is not a failure. It is a reflection of complexity, because when systems reach a certain level of scale, they begin to behave in ways that are difficult to reduce to simple explanations. Now, this might sound concerning, and in some ways, it is. But it is also what makes these systems so powerful, because that complexity allows for flexibility, adaptability, generalization, the ability to handle a wide range of tasks without being explicitly programmed for each one. This is what enables AI to write, analyze, translate, create, we are relying on systems that we do not completely understand, not blindly, but practically, because the benefits are too significant to ignore. And this is not the first time humanity has faced such a situation. We have used technologies before fully understanding them. Electricity, the human brain, even the internet itself in its early stages. Understanding often follows application, not the other way around. But AI feels different, because it is not just a tool. It is a system that processes information in ways that resemble aspects of human cognition. Not identical, but similar in complexity. And that similarity raises deeper questions. About intelligence, about decision-making, about control. Because when a system can generate ideas, solve problems, and adapt to new situations, it starts to blur the line between tool and agent. Not conscious, not aware, but capable. And capability changes expectations. Now, here is something that makes this even more intriguing. Researchers are beginning to discover that some of these systems develop internal structures that resemble reasoning. Not true reasoning in the human sense, but approximations of it. They can break down problems, evaluate options, produce step-by-step solutions. And while this is incredibly useful, it also adds another layer of mystery. Because the system was not explicitly programmed to reason in that way. It learned to approximate it from data, from patterns, from exposure. And that brings us back to the core issue. Understanding not just what the system does, but how it arrives there. Because as these systems become more integrated into critical areas, that understanding becomes more important. Not just for researchers, but for society as a whole. Questions of trust, accountability, and transparency all depend on it. If an AI makes a recommendation, can we explain why? If it makes a mistake, can we trace the cause? If it behaves unexpectedly, can we predict when it might happen again? These are not simple questions, and the answers are still evolving. But here is the key point. Not fully understanding a system does not mean it is uncontrollable. It means it requires a different approach to control. One that focuses on outcomes, boundaries, testing, monitoring, and continuous improvement. Instead of trying to understand every internal detail, researchers focus on how the system behaves across a wide range of scenarios. They test edge cases, they evaluate performance, they identify patterns, and they build safeguards. This approach is not perfect, but it is practical, and it is how progress continues. Because stopping development until everything is fully understood is not realistic. Understanding grows alongside capability, step by step, iteration by iteration. So where does that leave us? With a system that is powerful, complex, and not yet fully understood. A system that is already shaping the world in subtle but significant ways. A system that represents both opportunity and challenge. And perhaps most importantly, a system that forces us to rethink what it means to understand intelligence. Because for a long time, understanding meant being able to explain something completely. Every step, every detail, every mechanism. But with modern AI, that definition is evolving. Understanding may not mean knowing everything. It may mean knowing enough to use it responsibly, to guide it effectively, to recognize its limits, and to continue learning as it evolves. So when people talk about the AI system that no one fully understands yet, they are not describing a failure. They are describing a frontier, a boundary between what we know and what we are still discovering. And like every frontier, it comes with uncertainty, but also possibility. Because the same complexity that makes these systems hard to understand is what makes them capable of solving problems we have not been able to solve before. And that is the balance we are navigating right now. Between knowledge and discovery. Between control and capability. Between certainty and progress. So the next time you hear about an AI system doing something impressive, remember this. Behind that output is a process that may not be fully visible. A system that is still being explored, still being understood, still evolving. And that is not something to fear, but it is something to respect. Because we are not just building tools anymore. We are building systems that challenge how we define intelligence itself. And we are only just beginning to understand what that really means.